Hello everyone. We're finishing up Unit 11, Section 10.4, where we're using inscribed angles and polygons. So let's first talk about the definitions here. Inscribed angle. An inscribed angle is an angle that will have a vertex on the circle. Okay, the angle then is inscribed inside the circle. The sides of your angle are chords of the circle, and so in the example over here at right, angle ABC is the inscribed angle. Now the intercepted arc is the part of the circumference, it's the arc that lies on the circle, on the interior of an inscribed angle. So if you thought about this, the sides of this angle intercepting the circle and kind of cutting out a chunk, it's the part of the circumference, the arc that's between the two sides of the angle. The endpoints are on the angle, and in this example, AC is the intercepted arc, and so we would write that AC with the circle above it, arc. And that's what this is supposed to be. It doesn't look quite circular, but that's the best we could get. All right, let's talk about how we get the measure of an inscribed angle. So if we're looking at the measure of that angle right there, angle X, we notice that the arc that that angle intercepts is 2 times the angle. Or we can look at that as the angle is half of the arc. And so I try to tell my students, I like to start looking at this as the angle measure equals half of the arc. Now, why I like to look at it that way is this idea of taking the arc measure and dividing by 2. And you'll understand as we get into some of the next slides why that's important. It starts getting to be a theme that we do stuff, we add or we subtract and we divide by 2. So it's just a common theme. All right, let's move on. So let's look at this. If we want to find, like for A, the measure of angle T, I'm looking for this angle right here. Notice that the vertex is on the circle, and whenever your vertex is on the circle, we want to look at the arc that that angle intercepts. So if I extend those lines, we can see clearly this is the arc right there that the angle intercepts. The angle measure is, or the arc measure, sorry, the arc measure is 48. So the measure of angle T equals the arc divided by 2. And so that measure of the angle is 24 degrees. Now, what's the measure of arc QT? Let's look at, here's the angle R. Let me pick a different color. The angle R that intercepts arc QT. And so if you remember, the angle measure is half of the arc. And if we want to keep writing in that way, we would say the angle measure equals QT, I guess I'm just going to write QT, that's what I'm solving for, divided by 2. And so how would we solve for QT? We would multiply by 2. And so the measure of QT, the arc, is 100 degrees. That is the arc measure. Okay, so what is the measure of arc QR? Okay, we're going to have to leave QR off of this one. I drew this one wrong. Well, here, maybe what I'll do is go down here. We need a circle. Now, a center. Whenever you see the dot in the center of your circle, if it goes through the line, then that implies that, or shows me that that's a diameter, correct? And so when I drew this, I failed to pay attention to that I'm supposed to have the center. And what that gives me, remember that angle R here is 50 degrees, right? And so we know that's 50 degrees for that angle. We found that arc QT then was 100 degrees. And that kind of went off the edge there. But that the arc is 100 degrees. So this piece of the arc right here is 100 degrees. Well, remember that if this is a diameter, it cuts my circle in half, right? And we know the distance around the whole circle, the degree measure is 360. And so we would also know that half of that circle then, the angle that's intercepting at the center of it here, 180 degree angle, so the arc measure is 180 degrees also. Now, if we want just Q right here to R, then I look at this piece, QT, is 100. Well, that's going to leave me 80 degrees for the measure of QR. So I guess we can go ahead and do it. I just needed to redraw it. So the measure of QR here, the arc, would be 80 degrees. So that's another thing that you want to look for, is that we want to look for diameters. If you have a diameter, then you know this arc is also 180 degrees. Okay? So look for those diameters. Okay, next. Find the measure of angle of arc RS and the measure of STR. So let's follow STR. This is the angle I'm looking for right there. So let's first take a look at this. We've got SR right here that we're looking for, the arc. Notice that the angle that intercepts this arc right here is this angle 31. Well, doesn't this angle over here at T, let's use a different color, we'll extend the sides of that angle, and notice that they intercept the same little chunk of arc. So first of all, to find the arc measure, RS, the arc, we know that we have to take the angle and multiply by 2. So that's going to be 31 times 2, which is 62. That's 62 degrees for the arc. What we also need to look at is arc RS being 62 degrees makes this angle T right here the exact same measure. Angle STR equals 62 because that is the arc that it intercepts divided by 31. Divided by, go back, divided by 2, which is 31 degrees. And so if you look at the rest of the question, what do you notice about angle STR and angle RUS? They happen to be the same, right? Angle STR is congruent to angle RUS. So let's move to the next slide and think about that for a minute. Here we go. Here's your theorem then that we get from that. If two inscribed angles intercept the same arc, then they are congruent. They have to be congruent. If they intercept the same arc, then they are going to be congruent angles. Okay, next, we get some more theorems. The inscribed polygon. Inscribed, so again, as well as inscribed angles, we look at an inscribed polygon, and those are going to be inside the circle. This is going to be a polygon inside a circle where all the vertices are on the circle, the vertices of the entire polygon. Each vertice is on the circle. So here's an inscribed triangle, and then we have an inscribed quadrilateral. All vertices are on the circle. A circumscribed circle is the name that we call the circle that has been drawn around these polygons. Those are circumscribed circles. And then last, we get one more theorem here, that a right triangle is inscribed in a circle if and only if, and this is a term that you'll probably hear throughout math, is depending on how far you go. You'll definitely hear it on into pre-cal and calculus, a little bit in algebra too. If and only if. So this is IFF for your shortcut you might hear, or CIFF, and that means if and only if the hypotenuse of your right triangle is a diameter. So what that says is, if I'm going to have a right triangle, the hypotenuse of it has to be the diameter. Okay, the hypotenuse will be a diameter. Okay, Theorem 1010 says that a quadrilateral can be inscribed in a circle if and only if, there's our term again, if and only if its opposite angles are supplementary. So we have to pay attention to the fact that just because it's a quadrilateral, and if you remember quadrilaterals before, we talked about consecutive being supplementary. But when we inscribe it in a circle, then its opposite angles. And this is going to be real important for you to listen to and understand. Its opposite angles are supplementary. So that means the measure of angle A plus the measure of angle C is going to equal 180 degrees. Opposite angles supplementary. So let's find the value of the variables here. We know that angle A and angle C here, so y plus 68 has to equal 180 degrees. And so when I subtract the 68, that's going to make y equal to 98 degrees. Okay, and then we do the same thing for x. Got y, so x plus 82 equals 180. So that's going to make x equal 112 degrees. Okay? Now let's take a look at B. This is where we get a little more of our algebraic. So remember algebra, that we have to set the opposite angles equal to 180 degrees. Let me do a different color now. And so I'm going to say y plus 2y minus 6 equals 180. Okay? Now, y plus 2y is going to give me 3y. And let's go ahead and add that 6 to the other side. 3y is going to equal 186. Now, when I divide by 3, y equals 62. Okay, so y up here, y degrees, that's 62. And remember that they have to be supplementary. So we could subtract that 62 from 180 to get the angle down here at u, or we can plug it in right there for y. Now let's find x. Now opposite angles, supplementary, right? 10x plus 8x equals 180. So we get 18x equals 180 degrees, and again, when we solve for x now, we're going to get 10. Now, I shouldn't have said over here that y is 62 degrees. 62 is the answer, but I have to plug it in here to figure out what the degrees are for this measure, so it doesn't mean it's an angle measure. X is 10, so I would plug that in here for V and for T to get the angle measures if asked. All right, here we are in section 10.5 now. Last one, other angle relationships in circles. We have theorem 10.11 that says if I have a tangent line and a chord that intersect at a point on a circle, then the measure of each angle formed is half the measure of the intercepted arc. So really think about this. What we have is the vertex of an angle that's on my circle. And don't we already have a theorem for that? That says if the vertex is on the circle, that the angle measure is half of the intercepted arc. Well, the intercepted arc here is just the arc that starts where the tangent and the chord intersect, and then it goes all the way around to where that line, the other side of the angle, hits the circle. And so this is my intercepted arc. It is 210 degrees. That's going to make angle 1, I should have said the measure of angle 1 equals 210 and divide by 2. If the vertex is on the circle, we take the arc and divide by 2. So the measure of angle 1 is 105, half of the arc. Okay, so look at B, the measure of the arc. Now, why there's a middle letter there is that it gives me the direction. It means that I want to start at R, I want to go through S, and then end up over here at T, and that's the arc I'm looking for, the arc RST. And so to get that, we would take the angle measure that intercepts this arc, which is the 98, and multiply by 2, because the arc is twice as big as the angle, 2 times the angle. So the measure of RST would be 98 times 2, and that's 196. Okay? I think you guys have the idea. The measure of XY, and so here I'm going to go XY, okay? Angle measure that they gave me And see, and this is why they didn't give me a dot here in the middle to tell me which direction, but if this is the angle that's listed 80, then I'm going to look at the XY here that is the arc that that angle measure intercepts. And so that measure is going to be 160. Now, if they wanted the other arc, if they wanted this arc, if they wanted this one, they would have given me a dot over here and said that this is W. And then we would have said XWY. Now, if that's the case, then I want to either take the 80 degrees here, subtract it from 180 to get this angle measure, which then would be 100. That's not a great 100, is it? And then we know that arc would be twice that, so the arc, the measure of arc YWX would be twice that, 200. Okay? Let's move on. Next one, intersecting lines and circles. So here's where we start talking about different ways to find the angle measures. And what we're looking at here, the vertex of the angle is on the circle. Now we already know how to find angle measures when my vertex is on the circle, right? The angle measure is half of the arc. So the angle is half the arc. Now, when I'm inside the circle, so say I have two intersecting lines or chords, this angle measure then is going to be inside my circle. The vertex is inside the circle, but is not at the center. Because remember, if I'm at the center, then the angle measure and the arc measure are exactly the same. But here I'm inside the circle, not the center. Now, if my angle measure is outside the circle, then my vertex here, you'll see my lines intersect outside the circle. So let's look at what that means. The angle inside the circle theorem says that if I have two chords or lines that intersect inside the circle, then the measure of each angle is 1/2 the sum of the measures of the arc that's intercepted and its vertical angle. So that means the arc that the vertical angle intercepts. So if I want the measure of angle 1, that's going to equal the arc it intercepts, which is DC. So we're going to take DC, and it says up here sum, so I have to add its vertical angle, and there's the vertical angle to 1. The arc that's intercepted by the vertical angle is AB. So I'm going to add arcs, AB, and divide by 2. And here's that theme that we start talking about, dividing by 2. If I'm inside, I add arcs and I divide by 2. Now once I did that, I could subtract. That would give me this angle measure right there. If I add these two arcs, AB and DC, and divide by 2, that gives me angle 1 and it's vertical. They're the same measure, correct? If I wanted 2 then, I would have to subtract angle 1's measure from 180 degrees to get 2. Okay? Okay, so let's find the measure of this angle X. To get the measure of angle X, remember that we add the two arcs, the arc that it intercepts, which is this one, that's 156, plus the arc that its vertical angle intercepts, 130, and I'm going to divide by 2. So 156 plus 130 is 286, and then we got to divide that by 2. So the measure of angle X equals 286 divided by 2. So that's going to be 143, and that's going to be the measure of angle X. Now remember, if I wanted this angle, say this angle right here is Y, well, to get Y, I could, since I've already found this angle, angle X is 143, I could subtract that from 180 to get angle Y. Now why is that important? Because a lot of times you'll be given this arc and this arc, but the angle that they're looking for is Y. So if you're given these two angles, remember that if you add these and divide by 2, you're getting this angle and this angle, the angle that intercepts those two specific arcs, not Y. you have to get this angle first that those arcs are intercepted by, and then subtract from 180 to get y. Okay, let's move on. We're going to find the measure of angle y inside the circle. Okay, we want the measure of, not angle, sorry, cross that out, not angle, arc. We want the measure of arc y. So we want to figure out what is the degree measure of this arc right here. Now remember that the angle that we're looking, or that we need for this arc and this arc, to add these two arcs and divide by 2 is going to give me this angle right here. Now, can I find that angle measure? Sure. We can take the 102 and subtract it from the 180. That gives me 78 degrees. 78 degrees. Okay, now a lot of the times you're going to have to remember the way that we write these equations, which is that the angle measure, 78, equals the sum of the two arcs. I know the top one is y. I don't know what its measure is. But if I add y to the other arc that 78 intercepts, the 95, and divide by 2, it gives me the angle measure, right? So the angle measure equals the sum of the two arcs divided by 2. Well, we know we have to solve for y. Got to get rid of this fraction. So the first thing I want to do over here on the right side is to multiply by 2, and that's going to clear my fraction. So I'm going to multiply the left side by 2. Those 2's then cancel, and over here I'm going to get the y plus 95 equals 2 times 78. That's 156. Now subtract the 95, and y equals the arc measure, and that arc measure equals 61. Okay, so the arc measure is 61 degrees. Next slide. All right, the angles outside the circle theorem. Basically what this says is if my angle is outside the circle, then I'm going to subtract the two arcs, the smaller arc from the larger arc, and we'll divide by 2 again. So there's 3 different cases we're going to see. We might have one tangent where it touches at one spot and then a secant. We may have 2 tangents, or we may have 2 secants that go directly through the circle in 2 spots. But my theorem is going to remain the same. What I do remains the same. I'm going to subtract the arcs. So let's just look at the first one. If I want the measure of angle 1, I'm going to take the larger arc that angle intercepts, which is arc BC, and I'm going to subtract from it the smaller arc, which is AC, and then divide by 2. Okay, let's look at the next one. The measure of angle 2. I'm going to take the larger arc, which starts where that angle intercepts. I have to go all the way around to get the larger arc, which is going to be PQR. Subtract the smaller arc, and that's the inside arc that angle intercepts again, PR, and I've got to divide that all by 2 to get the angle measure. Okay, I think you guys get the idea, so I'm going to move on to the example. Now, you know what? Hold on, I'm going to do 3. The measure, I'm going to write it down here, of angle 3, here, outside arc that angle intercepts, so the arc is, the larger arc is XY, and I'm going to subtract the smaller arc of WZ and divide by 2. So let's go look at an example now. Find the measure of angle X outside the circle. Again, oh my goodness, I wrote angle, but this measure out here is for this arc. So that should say arc X. I am so sorry. Find the measure of arc X outside the circle. So write it the way we say the equation. The measure of the angle. Measure of the angle is 30 degrees. So the measure of the angle equals the larger arc, which is X, minus the smaller arc, 44, and divide by 2. Again, we've got a fraction with 2 on the bottom. Let's multiply both sides by 2. So I'm going to get 60 on the left equals x minus 44 on the right, because those 2's will cancel. Now if I add 44, I'm going to get 104 equals x. And so that x is going to be 104 degrees. Okay, so regardless of which you see, you are going to take the larger arc and subtract the smaller arc and divide by 2 to get your angle measure. So angle measure equals larger arc minus smaller arc and divide by 2. Now your teacher may have a special way to help you remember when I'm inside that you add the 2 arcs and divide by 2, or when you're outside you subtract arcs and divide by 2. The only way really that I have found that I've used with my students, and tell me if your teacher has one that you like better, make sure they tell me. But the way I tell mine to remember is that we live in Texas where it's hot. So the air conditioning is on all the time. I don't know about you, but I get very cold in air conditioning. So I think about when I'm inside and it's really cold, I add a jacket. When I'm inside, I add a jacket, or I add a layer of clothing because I'm freezing. When I'm outside, I subtract or take off that jacket because it's so hot. Okay, so it's silly, but let me know. Maybe it'll help you remember. If you're inside, you add arcs and divide by 2 to get the angle measure, and if you're outside, you subtract arcs and divide by 2. And remember, if you're subtracting, you have to do the smaller arc from the larger arc because you need a positive number. So inside we add, outside subtract. If I'm on the vertex, if my vertex is on the circle, then it's just half of the arc. I just take the arc and divide by 2. And if my vertex is in the center, then the angle measure and the arc measure are exactly the same. All right, y'all. Good luck, and let us know when you have questions.